In this video, we'll be learning about the distance formula. By the end of this video, you will be able to find the distance between any 2 points on the xy plane using the distance formula. Before I give you the distance formula, let's look at an example and try to figure out where the formula comes from. Let's try to find the distance between the points P1 with coordinates 3, 5 and P2 with coordinates -4, 2. We'll start by plotting the points P1 and P2 on the xy plane. P1 has coordinates 3, 5, and P2 has coordinates -4, 2, so we get a point here. Now, if we want to find the distance between P1 and P2, essentially what we're looking for is the length of the line segment connecting these 2 points. To find the length of this line segment, what we can do is draw a triangle. From P2, I'm just going to draw a horizontal line straight across, and from P1, I'm going to draw a vertical line straight down. What we've formed here is a right triangle, and so if we want to find the length of that blue line segment, what we can do is use the Pythagorean theorem. Let's label the sides of this triangle A, B, and C. According to the Pythagorean theorem, we know that a squared plus b squared is equal to c squared. Since we're interested in the length of the hypotenuse, we'll solve for c. Taking the square root of both sides, we get c equals square root of a squared plus b squared. Let's try to find a. The line segment A begins at the x-coordinate of P2, which is -4, and ends at the x-coordinate of P1, which is 3. Notice that the length of A is the distance between the numbers -4 and 3. And if I want to find the distance between two numbers, I take the absolute value of the difference of the two numbers. So we have that A is equal to the absolute value of 3 minus -4, which is the absolute value of 3 plus 4, or 7. In this case, 7 is already a positive number, so the absolute value isn't doing anything. So we found here that the length of A is 7. Similarly, the line segment B begins at the y-coordinate of P2, which is 2, and ends at the y-coordinate of P1, which is 5. If I want the length of B, I'm interested in the distance between the numbers 2 and 5. And again, to find the distance between two numbers, we take the absolute value of the difference between the numbers. So B is the absolute value of 5 minus 2. 5 minus 2 is 3, and the absolute value of 3 is just 3. Now that we have both lengths A and B, we can find the length of C using the Pythagorean theorem. So C is equal to the square root of a squared plus b squared. A is 7, so we have 7 squared, plus b is 3, so we have plus 3 squared. Simplifying this, we have c equals square root of 49 plus 9, which is square root of 58. So that is the distance between our 2 points P1 and P2. We can take what we did here and try to generalize this for any 2 arbitrary points. So let's say I have P1 with coordinates x1 and y1, and P2 with coordinates x2 and y2. Then the distance between P1 and P2 will be given by the formula distance equals square root of x1 minus x2 squared plus y1 minus y2 squared. This formula essentially comes from the Pythagorean theorem. The distance between our 2 points is the hypotenuse c. And from the Pythagorean theorem, solving for c, we get c equals square root of a squared plus b squared, where a and b are the sides of the triangle. To get the base of the triangle, we take the absolute value of the difference between the x-coordinates of our points, and to get the height of the triangle, we take the absolute value of the difference between the y-coordinates of our points. We see those differences here in the distance formula. The x1 minus x2, that's the difference between the x-coordinates, the y1 minus y2, that's the difference between the y coordinates of our points. You might notice that there aren't any absolute values in our formulas. We just have x1 minus x2 squared. But it turns out we don't need the absolute values, because if x1 minus x2 is negative, when we square that quantity, it's going to become positive. Same thing with the y's. y1 minus y2, we don't have absolute values around them because we're squaring. The square will turn any negative numbers into positive numbers. So the absolute values aren't necessary. With our distance formula here, we can find the distance between any pair of points. So let's look at an example where we use this formula. So in this example, we're asked to find the distance between the points P1, which has coordinates 1, 3, and P2, which has coordinates 5, -2. Remember that our distance formula is distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Remember that x1, y1 are the coordinates of my first point, and x2, y2 are the coordinates of the second point. So let's try to plug in the appropriate numbers into this formula. We have the square root of x1 minus x2 squared. x1, again, is the first x coordinate, so that's 1. x2 is the second x coordinate, which is 5. So we have 1 minus 5 squared. y1 is the first y coordinate, which in this case is 3, and y2 is the second y coordinate, which is -2. So this gives us 3 minus -2 squared. Let's simplify this. We have square root of 1 minus 5, so that's -4 squared, plus 3 minus -2. So that's 3 plus 2, or 5 squared. Simplifying this further, we have square root of 16, that's -4 squared, plus 25, which is 5 squared. Adding 16 and 25, we get square root of 41. So the distance between the 2 points P1 and P2 is square root of 41. So this is how we use the distance formula to find the distance between 2 points on the xy plane. And that's it for this video. In our next video, we'll talk about finding the midpoint between any 2 points.